Hello everyone, welcome to Computer Science E76. My name is Dan Armendariz. This is the start of the Android portion of the course. In the next 5 weeks we're going to start to dive into the Android SDK. Now before we can actually get around to doing that, we do have to make sure that everybody is sort of up to speed on the language that the Android SDK actually uses, which is essentially Java. And so that is what we're going to be talking about today. Today is mostly just a Java primer so that everybody that has varying degrees of familiarity with Java will at least be at sort of a minimum baseline. Of course, it would be unreasonable to expect that we would be able to go over the entire language in the next 2 hours, but similarly, we have not been able to go over all of the HTML5 stuff the past 2 weeks, nor will we be able to go over all of the Android SDK in the next few weeks as well. And so there might be, if you feel less comfortable with it, we do have a variety of sections and office hours that you should feel free to attend to get some additional help. And speaking of sections and office hours, there seems to be some confusion about all of these resources that we have made available to all of you. So we have basically a small army of TFs, and our TFs are doing a variety of things, including grading and leading a variety of sections and office hours and labs and these sorts of things. And really each one is designed to do something different. Sections are local based, but some of them will be filmed and placed online, and it's really just a more intimate way to review the material that we talked about in lecture. And we might go into, in sections, a little bit more detail about some things that we had talked about in lecture that perhaps we had to gloss over due to time, or we just did not happen to go into enough detail that you would have liked. And it's really a great way to ask some more questions as well that you may not have had a chance to do in lecture. So the way that labs are different from sections is that labs are in a computer lab, so it's really much more hands-on. So it's a more hands-on way of working with the same lecture material. So whereas in section, you'll be talking about all of the things in lab, you'll actually be able to use a computer, and perhaps the dynamic will be a little bit different in that respect as well. Now, this is not to say that the local students are at a disadvantage, because we do also offer online sections via Elluminate. And so Elluminate is basically the online version of this section that we've been talking about, and I suppose it's a bit of a lab as well, since you're by nature forced to sit at a computer and perhaps work through some of these things there. Now, Elluminate sections will also be recorded in an Elluminate fashion, not in a video camera fashion, and the recording will be placed online as well. Now, in addition to that, we will also have walkthroughs. Now, walkthroughs will happen once every couple of weeks and are really designed to help you out with the project. So whereas the sections, the labs, the Elluminate section, all of these are really meant to help you with the lecture material, they really may not touch on some of the specifics from the projects that have been released. So a lot of the questions that have come up lately involve things about, how do I get started on this HTML project? Well, that is exactly what the walkthrough will help you with. It's sort of like a section in that it's smaller, but it is designed to help get you started on these topics that might be useful in the project itself. And finally, we have office hours. And office hours are meant to be more one-on-one with the TF, where if you have a very specific question, perhaps you are working on the project and you're running into a problem, you can't seem to solve it on your own, office hours are a great way to get some help with that. The TF will be able to help you specifically, or perhaps if there's sort of an overarching problem, then help people in general with all of the things that they're running into. So hopefully that makes clear some of these resources that we have available. And when we're talking about the projects, realize that we did actually make one small change to the Project 1 specification. No longer is JSLint a requirement. So no longer do you have to validate your JavaScript using JSLint, just because it was being sort of problematic. And so for that feature has been done away with, and you can see, of course, an update on the class website. Now, this first project is not due until next week, I believe, but we actually have also released the first Android project that will be due in 2 weeks hence. And that one is the setup project of Android, and it's really not meant to be very involved, especially not as involved as the HTML project or the next Android project that will come out after this, the staff's choice, but it is meant as a way to help you get started with Android and the SDK. We will talk more about what the SDK is and how it works with Eclipse and what all of the tools are and that sort of thing next week, but this will help you get started with the Android SDK on your own computer. How do you install it? It's not frankly, it's not the easiest thing, it's not the most trivial thing in the world to get the Android SDK installed. And so there are a couple pages of instructions to help you do that. And in addition to this, not only will you get the Android SDK and Eclipse all installed and ready to go on your own computer, but really one of the aspects of this project is to just create the most basic of Hello World applications, your very first native Android application, and it is that you will submit to us. Now, looking forward ahead a little bit to some of the projects down the road, after this one we will have the staff's choice, which will be quite a bit more complex, and it will be more along the lines of the workload that you have with the HTML project. But beyond that, you will have the student's choice project, and that is your choice, what you want to do for a project. Maybe you came into this class with an idea that you want to see for a native application on Android and or iPhone, and this will be the opportunity for you to get started on that application. Now, with that said, we can't just let you get started on any application that you want willy-nilly just because maybe it's not complex enough of a scope, or maybe it's too complex of a scope to be submitted as a project for this class. And so with that, the last and final thing that you will do for this, this setup project is to actually submit a proposal for your student's choice. So you have to start thinking about what you want to achieve in your student's choice project, which is, of course, a few weeks hence. But submitting a proposal to us will allow us to look at it and help you so that you know and that we know that you will be able to accomplish the task. Now, of course, just by submitting a proposal doesn't mean that it's set in stone. You can actually, if you decide at a later point that you want to change the proposal, you can email your TF and we will be able to accommodate. But this just is supposed to get you started thinking about what to do. And of course, sitting here now, when we haven't even started looking at Java or the Android SDK, you may have no idea what your capability will be in a few weeks. And that is sort of the other goal of this proposal, is maybe you'll have an idea, we'll be able to tell you if it's going to be realistic or not based on the topics that we're going to address. Any questions on any of this sort of administrative stuff before we start diving in? Yes?
I haven't read the assignment, but my general question is whether we have to submit just one proposal, or is it okay to submit multiple alternative ideas so that we can see, you know, which one is better, which one the TA likes the most?
It's better to submit it's better to submit one proposal. But what you can do is in that same proposal, if you have an alternate idea that you're considering, you can sort of pose it in the same proposal. So you'll notice that in this PDF, there's actually a link through which you will submit your proposal. And just submit the one. We'll only look at the most recent proposal from you. So if you have an alternate idea, I would sort of just submit a little bit of information about that at the same time, but I wouldn't go all out. I think you might have one, if you are considering a variety of them, you might have one that you prefer, and that's really the basis for the proposal, but you can, of course, list the others as well. Yes?
Totally administrative question. But at the end of the assignment, it says you're going to submit this to a Dropbox with your teaching fellow's name, but given that the sections are kind of fluid, and how do you decide which TF to?
Actually, let's see. Tell me, we signed.
We haven't assigned. You will be assigned a teaching fellow. We will put your assignment in that Dropbox. We just haven't done that process yet.
Okay.
You will receive a teaching fellow.
So we'll get an email and then we'll know which one.
Yes.
Okay.
So to repeat for the camera, you will be assigned, you have not yet, but you will be assigned a specific TF who will be grading. So in both projects, we refer to your TF, and that is the TF that you will be assigned to. And you will upload your projects to that TF, that TF's Dropbox in the submit URL that's found at the bottom of both of those projects. Okay. So with that said, we do need to talk a little bit about Java. Now, it's really difficult to say that Android is Java. That's not really accurate, I would say, just because, sure, it uses the Java language, it uses the Java syntax, and you'll be hard-pressed to find some differences, but there is one very, very important difference between the Android Java and the Java that you might actually write an application on your desktop, and that is the complete lack of some of the libraries that Java has available. There's a lot of additional or a lot of replacement libraries that Google has provided in the Android SDK. So some of the things that you're going to see today are very generic to Java, but cannot be replicated precisely in Android just because those libraries may not exist in the Android SDK. And there's another reason as well, and that has to deal with the virtual machine. So typically, when you write a Java application, you're writing code just like you would for any other programming language, but instead of this code being compiled into an actual executable, it's compiled into something that's called bytecode. And this bytecode is this sort of intermediate state, which is not so specific to a platform. It is compiled in the sense that it has been converted to some other state, but it is not compiled in the sense that it is very specific to one platform. So as an example, if you were to write a program in C and compile that program will work on whatever platform you targeted it for. So it might work on a Macintosh, for example. It might work on a Linux computer with a certain set of libraries, and it might work on a Windows machine, but really that one binary, that one executable cannot be ported from one platform to another. And this is a very common problem that I'm sure you've experienced, just because you have to have multiple binaries available for a variety of platforms. You would have one available for Windows, one available for Mac, one available for Linux, and this is sort of that problem encapsulated. So the idea behind Java is that you could write code and compile it into this bytecode, and that bytecode could then be used on any platform. And the way that we are able to do this is through something called the Java Virtual Machine. And so there's this idea that the Java Virtual Machine will actually take the bytecode and on the fly convert it to the specific bits that would operate on that platform. So what is specific then to the platform is not the bytecode itself, not the code that you write in Java, but rather the virtual machine. So on your computer, on most of your computers, you probably have the Java Virtual Machine already installed. And what this does is it's that bridge between this generic bytecode and the specific platform that you are running. So this really allows for a lot of cross-platform. I mean, this was really the main idea, was that we would be able to write code and then be able to use it across all platforms. And it does work. It's a little bit slower just by nature of it being a virtual machine and it having to do some conversion on the fly while it's actually reading the bytecode, but it does actually work in this sense. So when we write Java code, there's a couple of things that we have to do. We first have to be able to compile that Java code, and then we have to run it in a virtual machine. And we will see how we can do this in just a few moments, but basically the result looks something very similar to this. By the way, I had mentioned in the Android project that you're going to be working on a Hello World program. If you're not familiar, Hello World is just the most basic of programs. It just says its whole purpose in life is to say Hello World, and that's it. And it's really just meant to be an introduction to get you to a point where you know the language enough that you can do something, frankly anything, with that language. And so we're looking at basically just a few lines of code in Java to create this Hello World program. So we'll go over what this code actually looks like in just a moment. But what's most interesting, I think, is if we take a look at how we ran this program. We didn't just type the command code1 into our terminal and hit enter. We actually had to run the command Java. So Java is this virtual machine, and we told Java where this bytecode is. This bytecode is called code1. So the virtual machine found that bytecode, interpreted it, and ran the program. So why is this important? This is important because, tying it back to Android, Android does not use the Java virtual machine. It uses a modification of that we'll talk more about next week, called the Dalvik virtual machine. So in this sense, it's also not Java. It's just it uses, again, the syntax, and it, for all intents and purposes, is Java, but the end result is not a Java program. It's not a Java executable. So with that said, though, we do have to realize that Java is very important to the SDK. We can't actually write applications without knowing them. And so, like I said earlier, knowing how to write applications in Java is going to make it possible for you to use the SDK that we start talking about next week. So first, if you want to take a look at some Java documentation, there's some pretty good documentation available on Oracle's site, or Sun's last year, now Oracle's. So the Java docs can be found on this URL, and the tutorial is also pretty good, where you'll be able to find getting started tutorials and that sort of thing. And so if we wanted to start talking about language, the very first thing is, how do we actually define a variable? Like how can we name a variable so that we can use it and store some data into it? Well, there's, just like any other language, Java has some rules to define a variable. And so these are those rules. It can start with letters, a $, or an underscore. Subsequent characters can also be numbers. So the very first character in a Java variable cannot be a number, just to make that clear. Of course, it's case sensitive, there's no spaces, that sort of thing. And typically the convention that you would see in a Java application is this sort of camel case where the first letter of the first word is not capitalized, but then the first letter of subsequent words is capitalized. That's just sort of, there's no real rule behind that. It's just sort of what you would see. Now, of course, for you to name variables, you can't actually name them some things. There are some actual reserved words that Java has that you cannot use in these variable names. And some of them are going to be obvious, but some may not. So how do we actually create our first Java program? Let's take a look at code 1. So the most basic example is just to print out the string, the text, hello world. So you'll notice that we have, if you're familiar with C or C++ or some other language like that, this might look a little bit interesting just because already are we hit in the face with some object-oriented programming. Right here, we have to define it within a class. And that is certainly true. In Java, you have to define everything within a class, especially your main function. So you might know that many programs know where to start their execution by way of a main function. And in this case, we have a main method that exists within a class in Java. So we've defined a class called code1. Within that class, we have defined a method called main right here. And that is what the Java virtual machine knows to begin and start your program. It looks for whatever class you have defined, and in that case, remember that we had run Java code1, meaning that we wanted to run the code within this class called code1, and it looked for that main function right there. Now, one of the interesting comparisons between this and Android next week is that there's not going to be a main method in Android. As you're going to see, we're actually going to dive directly into some of these classes. Yes? Yeah, I will zoom in a little bit to make it easier. Let's see. Is that more legible? Okay. Good. So, all right. So then we use, notice that we reference this thing called system.out.print, and we pass in this string as a parameter, hello world. And then after that, we have another command called system.out.println, which does what it sounds like. It just prints a new line, a line feed. And that's all that we have done in this application. So I'm sort of doing a little bit of hand waving at the class stuff, and I'm doing a little bit of hand waving at what is the system.out.print. But I think this will make a lot more sense as we dive a little bit further into it when we start talking about objects in Java specifically. Okay, so what does the next portion of our code actually do? What sort of things can we do in addition to this? Well, obviously, just printing out stuff is not going to be terribly interesting. You have to start to work with variables. And you can define variables just like you could in many other languages where you give them a type, and Java is very strictly typed, so you must give them a type and they must remain that way, unlike, say, PHP, where it just sort of has this nebulous type and you don't even define a type and you can change it left and right. But you must define a type when you define a variable. So here, in this case, the very first variable that we are defining in this function is a variable called another num, and we're giving it a type of int. And we are assigning this variable that we have defined a value of 3. So in Java, there are a few primitive data types that are actually pretty useful and that we will probably use quite often. These are the types here: byte, short, int, long, float, double, boolean, and char. Now, one thing that you will notice is missing from this is a string type. There's no string primitive type in Java. If we wanted to work with a string, we actually have to use an object that is called a string. And the way that you can tell a difference between a primitive type, which looks like this, and an object or a class is that the object or a class will always start with a capital letter. So string is one example that is an object. Big decimal is another example that is an object. So there's a class that has been defined somewhere that defines these objects. And these are not primitive data types anymore. They might use, at their most basic level, these primitive types, but these primitive types, notice, are not capitalized in the first letter. And that's one of the easiest ways that you can really tell. So whenever we have to work with strings, or whenever we want to work with strings, we're going to have to use the class called string. And we'll see how we can do that in just a little bit. But okay, assume that we want to work with just some of these primitive data types for now. Notice that we've done a couple of things. We can define local variables, so within the scope of the current method or the current function within Java, as we've done here. But we can also define field variables or variables that are accessible to any method within that class by defining it at the top of that class as well. So notice that we have defined at the very top private static int num. And that variable called num is then accessible by any method that exists in this entire class. And we will see right now this is sort of a poor example of why that might be useful, just because we only have the one method called main. But as we get down a little bit, of course, we will start to see how that is useful. Now, if we just wanted to print that out, we could use that system.out.println function and print it out. Now, notice that if you want to concatenate strings, the operator to use for that is the plus sign. So yes, the plus sign serves two purposes in Java. First, it can be used as sort of an addition, so you can do an arithmetic combination there, or you can concatenate two strings. It really depends on the context. So what matters is the first object in that addition. If it's a string, then it's going to perform a concatenation. As you can tell here, even though the num is an integer, it's actually doing a typecast for us into a string, just because it's assumed that we're doing a string concatenation here. All right, so what is the expected output of this program? It's not too complicated, but what do we expect it to say if I were to run this program? So the first line, yeah.
Print out num:2, and the next line would be another num:3.
Right, so what we expect is for it to say in the first line, num:2, then the next line, another num:3. So let's see what happens when we do that. Now, realize that in order for me to, if I make some change to this code, let's say that I had just written this code, I had just written this application, one of the things we have to do, remember, is first compile that application. Now, when I prepared all of these examples, I actually pre-compiled them all so I could run them immediately. But it is important every time, the first time you write a Java application, that you run the Java compiler on it. So javac space, then the name of the Java file, javac code2.java. After a while, if you don't see any errors, what will happen is that it will return, and that means that you have successfully compiled into bytecode your application. And so what does this look like then? Well, realize that we have a bunch of Java files in this directory, but also a bunch of class files. These .class files are that compiled bytecode that Java then is able to interpret. So when we run this java space code2 command, it is looking for a class file called code2 in the current directory. That's how this works, and that's why there's a lot of, it might seem like this sort of strange assumption that's going on, but this is how it knows what to look for. The Java virtual machine knows to look for a class file named code2 in this case. So I just compiled it, it just created it, so when I hit return, we should see exactly what we expected, num:2 and another num:3, just like we had said before. So just to give you an example of us actually modifying some of this code, let's actually change something here. So let's say that I want to change another num to, say, the number 5, and actually change what our code is going to do. So, all right, here we go. I've saved that, and I'm going to run it again. But now the code remains the same. It's the same thing. Yeah, I have to recompile it, exactly. So don't forget every time, and this applies even to your Android applications, and I've been guilty of doing this too, even though I know this, and I'm sure many of you have done the same thing over and over. You have to recompile it, otherwise the same thing will actually appear. Oops, code2.java. Now we can run Java again. Oops, Java code2. Let's see how we could do here. Now this time we have printed out another num=5. Okay, moving on.
So if you have a class that references another class, do you compile the one and you compile all of them, or do you have to compile them all?
Yes, if you have one class that also references another class because perhaps you have another class embedded in the same code, or you have imported from another file, it does actually compile separate class files for every class that you have. So it's possible to have more class files than you actually have source code files. And we'll see again, I've been doing a lot of, we'll see this later, but really we will see all of this stuff a little bit later. Okay, so moving on, let's take a look at this. Okay, so what we want to do is just do a couple of interesting things now, or some more interesting things with some of this data. So if we want to define a string, notice that we have to give our variable a type, but again, because a string is not a primitive data type, we have to start the data type, or we have to start this type with a capital S, string. So there is an object somewhere called string that we are instantiating into a variable called str, and we are then doing stuff with this. So we're printing out an integer, we're printing out a string, and if we want to actually, because the string itself is an object, and we want to make sure that we want to perform some method on it, then you can actually take a look at the Java doc for that object and see what sort of things are available to you. So in this case, just by loading up this URL, I can see now all of the methods that are available to me for a string object, and all of the various things that I can do. And one of the things that I'm doing in this code here is to take a substring, or to just pull out a subset of the characters that exist within the string and then print them out using system.out.println. So how does this look here? Well, all I have to do is type Java code 3. We can see that I have pulled out, using this substring method, the word world out of the string that was initially hello world. Okay, so all of this stuff is, I think, only marginally interesting. Let's move on to some of the interesting aspects of Java. Now, I mentioned before that Java is strictly typed, and so for this reason, we might get some things when you do some math, some arithmetic, you might actually get some things that you don't expect. So if you use an integer, for example, if you define an integer, let's say the number 123, and then divide that by 5, what is the number that you would expect as a result of that? Just the real actual value from doing that division. 123 divided by 5. Yep. 24 point something, right? Because it's actually going to create a decimal. Yep. Well, I mean, if we typed the number into our calculator, 123 divided by 5, the number that we expect out of that calculation would be 24.6. Well, yes, I mean, that is what happens, and that is the point of this discussion, is that because this is integer math, what you get out of it is another integer. So you're dividing one integer by another, you're not actually going to get a decimal out of it, you're not going to get a double, but you are in fact going to get an integer. And that's useful in some cases because you might actually want only the integer out of it, and you can also use the modulus to retrieve the remainder out of that value. So then we would get 24 as the result out of this integer division, and then 3 out of the result of the modulus, telling you exactly how much was remaining in this case. Now, if we actually wanted to overcome this issue, you'd have to do double math, which can be done through a variety of ways. One of the two numbers has to be a double in order for this to work. So in this case, we have defined a new variable that is a double rather than an integer, and we are dividing 123.0, which is itself a double, by this number 5, and we would get then the value that we expect. So just to show code 4 here. So like we had shown before, integer division, 123 divided by 5 is 24. The modulus is 3, and so on and so forth. And there's a couple of other ways that we can also convert the data type from one to another. All right, moving on a little bit here. Now, one of the things that we might want to do in our applications is to allow some input from the user. It's not going to be very useful if we're hard coding our data all of the time. So one of the ways that we can do this in Java is to use something called the scanner class. And so the way that we can use the scanner class is to instantiate a new object from this scanner class and allow it to ask query the user for an integer. So in this case, all I want to do is just ask the user for an integer and wait and see until we can actually retrieve that data from them. So how does this look rather than going through this code initially? Let's try this. Okay, so it looks like nothing is happening, but that's because all we did before was ask the question, or rather we had the scanner class just ask the user for some data. We didn't actually tell the user that we're expecting any data, so it's sort of this weird state right now. So if I know that I'm waiting for some data, enter a value like 5 and hit enter, then something happens with this data. So as you can see, the numbers don't match. So this might be something of a really cheap guessing game that I have to try to guess the number that this program has stored in memory. And so I could probably go for a long time, but I hope it's the same value, 123. And then it finally actually matches the numbers here. So as you can tell, we now have some additional control flow that's going on in this code, and it's very similar to what you've seen in JavaScript and in other languages as well. We can actually input the number into a variable. In this case, we've created a new variable called input of type integer. We've told the scanner class that we want to take its data that it retrieves from the user, put it as a value into this integer, and then we'll actually perform the test. If the input matches a number that we had defined above in this same method, then we're going to print out one of two things, dependent on the result of that question. So this if block and the else block is very similar to what you have already seen in many other languages as well. Any questions so far? Now, before, what we saw was something that was not terribly useful. It didn't prompt the user for anything. And if we had done something really horrible, like say I ran this and then I actually typed a string and hit enter, and we actually get this really nasty looking error, or rather it's something called an exception. Now, this isn't all of that great or all of that useful for us. And in fact, exceptions are something that are going to be, that you have to learn to handle in your applications. And as the applications grow to be more and more complicated, you will tend to have more and more exceptions that you have to handle. And there's ways that you can catch these exceptions that are thrown by portions of the code and do something so that you can actually prevent your code from crashing, prevent your application from crashing. But doing this, exception handling, is something that becomes very important, not only in Java, but also in the Android platform as well. So in code6.java, we actually want to see how we have made this perhaps a little bit better. Let's see. Wait, why does this look exactly the same? Number, int inputs. Okay, I'm going to skip 6 because that looks too similar to me. And now, here we go. Now we have some stuff. So in this case, what we want to do is try something. We put the code into a try block, whereas this was the exact code that caused that crash before. And had we actually read the exception, and that's something that we can do quite easily, right here, notice that it actually tells us what's going on. So if you actually read this exception, it gives you quite a bit of data. It says, exception in thread main, there is an input mismatch exception. So in the input, it's expecting some data, and what it got in the actual input is something different than what it was expecting. So it threw this exception that it had, and you can even see where this code had happened. If you go all the way down to the bottom, it says that it happened in code5.main, and it also gives a line number where this had happened. And had we actually looked at the file, we can see that on line 24 was that int input equals scanner dot input, where that actually retrieves the data from the user. So now instead what we are doing is we are putting this same thing into a try catch block. What we're doing is we are trying this thing, and if an exception is thrown, then we go down to this block right here that says catch. And now right here, you'll notice that I'm putting in parentheses exception E. And what this means is that I'm sort of taking the easy road in this case. I'm not catching the particular exception, the exact exception that was thrown, the input mismatch exception, but I am catching any exception that might have been thrown by the code above. And this is important because you might actually have different code that runs for different exceptions. Maybe the user input some text that was a string instead, and so that was actually that was invalid, or that was mismatched inputs. And so you could then tell the user, you could admonish the user that it's the wrong type of data and try again. Or maybe there was some other problem as well that you wanted to capture and tell the user, notify the user that something bad had happened. But in this case, I'm catching all of the exceptions that had been thrown, and what I want to do is tell the user that there's no input, there's no valid input, and I'm just going to quit on them. And this gives them a much more user-friendly way of notifying them that something bad has happened and that I want to make sure that they do it correctly the next time. So if I run this, now for once it actually allows the user a chance to know what's going on. And this was, I'm guessing, probably the thing that I skipped in code 6, is that it output just some text before we had the scanner class that allows the user to know what is happening. So it asks me to enter an integer. So now what I can do is enter an integer and see what happens. It's the same code as before. But now, if I do the same thing, where I ignore the instructions and enter a string instead, we catch the exception that was thrown in. Rather than having that nasty block of error code that we saw up above, we're actually outputting something useful to the user. Now, this is all well and good, except that this is still not very great, because if your program was a bit more complex and you wanted to do something like ask the user a whole bunch of questions, this is not going to be very good if after they've input a whole bunch of things, you decide to quit the application on them. What would be better is to decide, okay, well, now the user has tried to input an integer, but I got something else instead, so I'll just ask them again the same question to make sure that I can actually get some information. So, oh, no, that's okay. So that, in order for us to do that, we actually have to use a bit of a loop. And let's see, for us to, the type of loop that might be useful for us to do that would be a do while loop. If I can find where on earth I did this, which would allow us to, oh my goodness, okay, this must be much later. So let's come back to that, where we can actually ask the user over and over again what they want to be able to do, and instead take a look at some other control flow statements that we actually have. So in the JavaScript examples from last week, one of the things that we used was a switch to be able to decide, based on the input, based on some variable, to perform a variety of different things dependent on what the user had actually input. So in this case, what this is it just replaces an if-else statement where we ask the question, okay, if input is equal to 1, then we output something. If input is equal to 3, then we output something else. If input is equal to 6, then we output something else altogether. So we can try this and see what exactly happens. And this allows us to provide some really neat additional information to a user just by having a variety of responses ready for them. So for example, I can just try typing in some, numbers like this, and we can see the various things that this program would actually tell me. Okay. Now, besides this, the other sorts of things that we can do is to try to actually compare strings. So maybe now what we want to do is ask the user for a string and actually compare it to some other string that we have input. So in this case, what we want to do is to see if the user had typed in the phrase hello, comma, space, world, with the capitalization that you see here. Now, the way that we might be tempted to do this is very similar to what we've seen in the past, where we take the input and we compare it directly using this double equals sign notation to the string. So if string is double equals to input, then the strings match. Otherwise, we're going to get an error. So let's see what happens when I run this code. So what's going to happen if I type something else? Obviously, the strings are not going to match. That's good for us. But now if I try to type in exactly what I had in that in the variable before, we still see that for some reason it says that the strings do not match. And this brings up another very interesting point about Java specifically, and that is that everything is stored in Java by value. And specifically what that means is if you have a variable that is a primitive variable, for example, an integer, it's actually storing in memory, in the memory location for that integer, that value. Let's say we have the number 123 stored in an integer. The value of that integer is 123. But whenever you have an object, or whenever you have a variable, rather, that is of an object type, so in this case a string, then the value of that variable is not the object itself, it's not the string itself, but rather it is a reference to somewhere in memory which has, it's a reference to somewhere in the heap that has an instantiation of that object. So what this means is that all of these variables are actually really quite small. It's either a reference to a place in memory, or it is the exact data that's defined by the primitive data type. And this has some interesting implications for us when we try to work with some parameters in these methods. And of course, we'll see that at a later point in time. But this is actually a very important point. For this reason, because a string is not actually a primitive data type, we cannot use a direct comparison in this way. It does not work because what we are comparing are memory addresses, really. We're trying to compare the memory address that contains the object reference from string to this other memory address, and of course those are never going to be the same, at least not in this current case. So this will always be false. We will always get strings do not match in this case. So in Java, for us to be able to do something like string comparison, we're going to have to rely on methods provided to us by objects to be able to perform these very simple things. So in this case, in the method list for the string, one of the things is equals. We want to actually perform the test if one string equals another, just based on the contents of that string. And that method has been implemented by the developers of Java, or rather the developers who came up with the string class. They provided us this equals method that allows us to compare these two methods together. So now what I can see is if I actually run this code, I expect now that this will work as expected. So I can type some random string. We can see it does not match. And now if I try to type the proper string, hello world, we can see that the strings in this case actually do match. And this is the proper way to do comparison between two objects in Java. And this is going to be important. If you ever write a class or an object of your own in Java, you're going to have to make sure if this is something that makes sense. If you want to compare two objects together, perhaps because it is some more complex data type that you're working with, then it's important for you to implement some method like equals that will allow a user to allow a developer, besides yourself or even yourself, to compare two objects together to make sure that they match. Okay, moving on. Yes?
Does it care about white space? If you just did hello, comma, world, not a space, would it still consider it the same, or would it consider it?
So does it consider white space? So I would say yes and no, in that if you put two spaces here, what's going to happen is that the characters are actually different in the two strings because you have an extra character in these two strings that you're trying to match. Now, the way that it might not matter is if you are using if the scanner class does something like ignores a whole bunch of white space afterwards, or if you do something intentional like ignore the white space afterwards, then this might actually say, no, in this case it's still passing it, but you could potentially have some white space that either the scanner ignores and does not insert into the string, or that you intentionally do not ignore, or that you intentionally ignore rather, and then you can match those two strings. But in this case, the equals it's a literal equals, and it's actually comparing to make sure that every character is exactly the same in the entirety of the string. If any one character does not match, then we get this problem here. Okay, so all of this is great, but how do we actually work with some more data? So generally, you're not going to work with just one or two things, but perhaps you need to work with a lot of data all at once. And that is where something like an array can come in handy. So what you might want to do is define an array and store a whole bunch of data into it to be able to pull data out of it later. So let's say that I've implemented a gradebook and input one of your grades into it. So right now I've defined an array with 5 slots for grades rather, and I've input grades for each one. Now the way that we can define an array in Java is pretty simple. We can just use this sort of syntax right here, this double bracket syntax. And doing this after either a primitive or doing it after any type basically tells Java that we want to create an array in this variable called grade. So in this case, we've declared it. we've told the compiler that we want to create an array of type integer, but we haven't yet defined how big that array is going to be. In Java, you do not have dynamic arrays, at least in this sense. When you're defining it here, you can perhaps have dynamic arrays elsewhere. But what this means is that when you create an array and you define a certain number of slots within it, a certain number of indices, like in this case, in the very next line, we define a new integer array that has 5 indices within it, then you cannot change the number of indices that exist in this array. We're stuck for the duration of the runtime with 5 indices. Now that's good and bad in that, well, it's bad in that we really lose a lot of the dynamism that we might be able to have, but you can actually use some other methods. There do exist methods like ArrayList, or not methods rather, but objects like ArrayList and some other ones that implement more dynamic arrays that you can add objects to, you can remove objects from, and that are generally a little bit more flexible than this. But this is the most basic type, this is the most primitive type of array that you would find in the Java language. And you can, of course, assign values using the square bracket notation like you would see in many other languages as well, just like we did even in the local storage, where local storage almost acted in a way as an array that we could insert data into it and take data out of it. And you can retrieve data from each of the array indices in this way. So now, of course, when we start talking about arrays and we start using all sorts of large indices, and I mean, we don't even have that many indices in this case, but even just with the 5, we can see there's a lot of redundancy in our code. It's just starting to look kind of ugly and unnecessary. One of the ways that we can try to deal with this is to use loops. And using loops allow us to remove a lot of the redundancy when we're dealing with arrays, or a whole bunch of variety of code that we might have in other places as well, for us to be able to work with it. So in this case, what I want to do is define an array that has 5 indices, input a whole bunch of grades into each of those indices, and then iterate over all of the indices in that array to be able to retrieve the data from it. So in this case, I'm going to use a for loop that's defined like this. For int I is equal to 0, and I want to iterate I over all of iterate I over the length of the grades and increment I after every run. Then I'm going to print out grade number, so I plus 1, just because it is 0 index, don't forget, and so that means that I has to start at 0, even though we might consider it sort of the first number in the array. Numerically, it's the 0th number in that array. So we start from 0, and we say that the first grade is at location grades and in square brackets 0. So just by using a loop, can we make it much more clear what we are intending with this code? So we can really remove a lot of the redundancy that exists within this code. Okay, moving on now to code 13. Now, let's see. So there is an important optimization. Now, one of the things that we had seen in just the previous slice of code is that we used the test. Whenever we wanted to test to determine if we want to continue running this code, what we did was we asked the question, if I is less than grades.length. Now, this is fine, and this is something that's very typical for you to do, but there's a problem with this, and that is that every time you query, you ask this question, what is the length of an array, it has to calculate what the length of this array is, and this might actually be quite slow. And so in primitive arrays, this might not be quite so bad, but this matters especially when you're using dynamic arrays, arrays that have been implemented as objects, for example, so that array list, and that can actually cause quite a bit of extra computation. And in fact, many times, running this sort of method where you ask an array its length can take up to linear time, dependent on the length of the array, to calculate the size of this array. So asking this question when you don't expect the length of the array to change every time is wasteful, just because you are then causing this code to run multiple times, and this is not something that's going to work out quite so well when you're trying to develop efficient programs on a mobile platform. when you want to develop something that's very, very efficient, you want to minimize the number of cycles that you're using. So what if we instead pre-computed the length and stored that into a variable and then tested if I is less than that variable? Then this way we don't have to, every time this loop is run, we're not asking this question whether or not the length is, well, what the length is, and thereby causing some method to try to calculate the length of that array. We don't have to deal with that anymore. We can just ask the much more basic question, is one integer, the value of one integer, less than the value of another integer? And that is what we are doing here. So this small thing right here is actually quite a big and quite an important optimization that may not matter so much, frankly, for this application that's run on this laptop, just because we have enough cycles. It really doesn't matter that much. But when you're working on a mobile device that, yes, even though they're getting quite fast and they're becoming quite good, you want to optimize everything that you possibly can. And this is one small way that you can do that. So you can define two variables, define I, set I equal to 0, set j equal to the length of the array, and only do that once, and then you can move on. Okay, so moving on a little bit from here, let's see that what we can do using a different type of array altogether. So pretty much all of this code is essentially the same, where we declare array, we define it with a certain number of indices, and what we want to do is use a while loop, which is frankly just another construct for looping, which you've probably seen in other languages as well. So yes, while loop does exist in Java, and while some Boolean test evaluates to true, the contents of that while loop will continue to run. So while I is less than j, and in this case we've pre-computed j up there again, just to maintain that same optimization that we had seen before, then we're going to do a similar thing down here. So basically this is just a straight conversion from a for loop to a while loop to allow some other code to be run. Okay, so moving on from there, we have some other things. Now another still other type of loop that exists in Java is the do while loop. And what we want to do here is to perform the same thing again, but instead the difference between the while loop and the do while loop is that the do while loop is always performed at least once. In the while loop, like I said, there's that Boolean condition at the very top which says, okay, well, while something is true, that the contents of that loop will iterate. But what if at the very first iteration, what if that Boolean condition evaluated to false? That code will not run, and there's some cases where you actually want that code to run at least once. To guarantee that code to run in a while loop, you would have to have a copy of that code above the while loop just to make sure that it's run at least once. But rather than do all of that, you can reduce, again, some redundancy by having a do while loop, which ensures that it's run at least once. So in this case, if I somehow know, if I can guarantee that 0 is, in the case of I, is always less than the length of grades, so if I always have more than, or if I always have one index or more in an array, then I can safely do this. But I can do this. I can always print out the grade number and the value of that grade, and then I can perform the test here. So now notice something that's a little bit different. Whereas before we had something that said I++, the incrementer that we're using now is ++i. Now this may, this is sort of an interesting thing. What happens, the difference between ++i and I++ is the value that is returned. So if you are using ++i, this is still incrementing the value by 1, but what is returned is that computed value. So let's say that we have I is set equal to the value of 0 in this case. What will happen with ++i is that it will be incremented to 1, and then that value will be returned. So while 1 is less than 5. Now, had I changed this, and were this actually I++ instead, what will change is that it will return the previous value instead. So it would then return while 0 is less than 5. Even though after all of that line had run, after all of that code had run, I would still evaluate to 1. It's just the value that's returned is slightly different. So there's some cases that you might want to get the value before the increment, in which case you would use I++, and there's cases that you would want to use the opposite. You would want to get the value after the increment, which would be ++i. Okay, let's take a quick 5-minute break, and when we come back, we will continue diving into the world of Java. Hello, everyone. Welcome back from the 5-minute break. So I thought I would just mention quickly that walkthroughs will generally take the place of some normal sections. So in this case, the first walkthrough for the mobile local, the very first HTML5 Staff's Choice project is going to be immediately after lecture and led by Tommy. And so you can, of course, find this on the sections page. Any future walkthroughs will be shown on the same page, just so that you know which ones will be walkthroughs, which ones will be sections. And again, to reiterate, we differentiate between the different types of resources at the top of this sections page. Now, this walkthrough will be recorded and placed online. So for those of you at a distance, you'll still be able to take a look at what we have to say there as well. So moving on, we've started to take a look at some of the really basic syntax involved with Java. And whereas before code 8 or so, I started putting my foot in my mouth when I said, oh, let's start using the scanner class with the do-while loop instead of using this other stuff, and it really was supposed to happen much later, I can now say that this is the time that I can show you how to use this sort of thing and effectively use a do-while loop to ask a user repeatedly for input until it is actually the valid, until it is the type of input that you might expect. So looking here, how can we do this? Well, a do-while loop is sort of appropriate here because one of the things that we might want to do is always ask the user. We want to guarantee that we ask the user at least once for this data. This is probably one of the strongest reasons I think that we might want to use a do-while loop over a while loop. I've noticed in particular it seems to be kind of difficult using do-while loops. I think asking for user input is one of the times that it becomes really apparent and really useful. So anyway, what we want to do is set a variable, and in this case this variable is going to be called invalid, and it's just going to be a Boolean variable. Now this Boolean primitive type it's what it sounds like, and it can either be true or false. And at the onset we're going to assume that it is actually valid. So in this case, invalid is equal to false, which means that we're just making the assumption that this is going to be a valid input from the user. So next, what we do is we actually ask, and this is all in the do-while loop, and all in the do-while block that we have defined here. Now we actually want to ask the question from the user what their input is going to be. So we output some text that says, please enter an integer. Then we ask via the scanner class for the next integer available from the user. So the user enters an integer, and if we happen to notice that there is an exception, perhaps because the user has input the wrong type of data, then what we will do is admonish the user, tell them they're an idiot and that they need to re-input, and we're going to say that, okay, this Boolean variable, this invalid state is now true. And we are going to perform the test at the end of this do-while loop if, while this is actually invalid. So while we have an invalid data, we're going to continually ask the user until we receive valid data. Now you might notice that there is a keyboard dot next here. That's just to soak up the return key that the user had entered the moment before. Otherwise, what will happen is that you will get this sort of weird thing where you'll hit enter, enter the integer, you'll hit enter, and then what will happen is that it will assume the user entered an integer and then a return key. So we just have to make sure that we mitigate that problem in this case. So then the rest of this is pretty similar to what we have seen before. Well, I mean, we could do all of the tests if we wanted, but we can then finally tell the user that they've finally entered some valid input. So if we want to see what this is going to look like in action, I can actually run this Java code. Try running this. It says, okay, it's invalid input. Now I'll try something else. Okay, now it finally says that I've input a valid integer 12387. Okay, so we're starting to get up there a little bit in some of the more interesting things that we can do with Java, but really it's not going to be terrifically interesting until we can start to create methods, until we can start to create our own classes that we can then work with data, that we can do a bunch of things with the data that we are provided or that we want to do. So in this case, in code 17, we're going to start working with methods. So because we're working with objects, because we're working with classes in Java, we can create other functions by creating other methods within this same class. So just to prove this point here, let me make this a little bit bigger so that we don't get quite so much wrap. So in code 17, it's one class, and we still have to have our void main. We still have to have our main function that exists in here in order for us to run and execute this program. But we also have some other things as well. In this case, we have a constructor for the class so that we can initialize some fields. Then we can even use some setter and getter methods. One's where we can actually set some information, and another one where we can actually return some information. So there's a lot more going on here than what we've seen in the past. So in this case, what we are doing with this function right here, public code 17, and this in this case, this matches the name of the class. By convention, we are calling this the constructor. So whenever I instantiate a version of this class, and this is actually a valid class, just like we had seen even in the Hello World application, we had actually defined a valid class that we can instantiate if we wanted to, but now we are creating an actual class that has a constructor that allows us to instantiate it and perhaps set some and predefine some fields or predefine some values within those fields. And then we also have some additional methods as well. So basically, this is a very, very basic class. You can instantiate this class, and what that will do is that will set a field variable called num equal to 0. So this field variable at the very top here, you can see, is a private int, which means that only methods within this class have access to this variable called num that's held within it and can modify its value or retrieve its value. Now, what we want to do is have a class that can actually store some value. And that is exactly what this class does. When we first instantiate a copy of this class, we set num equal to 0. We just give it the default number to begin with. Then let's say that we want to actually set some value. So we can create now a new method called set and pass in as a parameter some value into it that allows us to set this field variable called num equal to this value that we've input. Now, of course, get we can then just use to return the value to the calling class or to the calling code that wants to know whatever the value of num happens to be. Now, for us to be able to use this, we just have to instantiate a version of the class. So keep in mind that creating a class like this basically means that it becomes a type. Excuse me, my throat is a little wonky today, so I'm sorry if I sound a little, I don't know, younger than I am. So anyway, so now what I want to do, this code 17 is actually a type. Now code 17 isn't all that meaningful of a type, right? It would probably be better had I called this class something else that's a little bit more appropriate for what this actually is, maybe like, I don't know, value, just because it will be able to input and retrieve a value from it. But in this case, this does prove a point that what we can do is create a new variable called myObject that is of type code 17. And within that, we can instantiate a copy of this object, create a new code 17 that then calls this constructor, public code 17, which then sets the field variable num equal to 0. Then we can actually use this variable as if it were this object. So now what we can do is we can set, we can retrieve the current value from num, and we can print that out and see what it actually is. Then we can reset that value to say something like 2, and then pull the new data out of it and see how this is actually reflected. So what happens when we run this is exactly what we said. First, we print out the value that it had defined by default, and then after we set it to a value of 2, then we print out that new value and see what's going on here as well. Now, moving on, we can do quite a bit more with this. And so this isn't all that useful if the code that I'm dealing with is actually in separate files. So I might have to find a car elsewhere, or rather I might have to find an object elsewhere, and I want to use that object in my class. So in this case, I'm defining a class called code18 that does a bunch of stuff. And in this case, it uses another object that's not even defined within this file. It's defined elsewhere, but because Java knows where to look for this class, it can find this object. It can find this class that it wants to work with. So you can see that there is a class somewhere called car. So there is another file in this source directory of car.java that defines a class called car, and it has a variety of field variables, and it has some methods, maybe a setter and a getter, and it probably does some interesting stuff. But that is, we're sort of abstracted from that, and that's really the whole point of all of these classes. It abstracts all of these things that we might want to do with some of this data so that we can create an object. And although this is sort of cheesy in that we're using an analogy of an object in computer science terms to be analogous for an actual object in real life, you can do that, but it can also be much more abstract than that, like a string, for example. A string is a pretty abstract object. It's just a collection of characters that exist in a computer, but we can also use it as sort of an analogy for an actual object as well. So we're creating two cars, one that's a tortoise and one that's a hare, and the slower one is a Toyota Camry, the faster one is some fancy Ferrari, and we're passing in some data into the constructor of the car to define some things. And then you can see that for each tortoise and the hare, we're setting something called max speed, and then we test something. We want to see if we can set the speed for each of these cars. So in this case, this is overly simplistic. We're completely ignoring acceleration and all of that sort of thing. But we're assuming that we can just sort of set these cars into motion and go at certain speeds. And what we're trying to do is to see if we can set the faster car to go 155 something. We haven't defined what speed, what the type of speed this would be. We can just arbitrarily say this will be miles an hour. So we'll try to see if we can set the speed. If something happens, if it returns true, as you can see here, then that means that we've successfully set the speed of this car, and we can print out either a success or failure dependent on the completion of this particular method. So now what else is happening in this same class is that we have two functions, print success and print failure. And we accept as parameters for both of these methods a variable of type car. So just because we've defined a car, and you might have noticed in other methods where we sort of hand waved at the parameter passing, you do have to define, because in Java it's strict typing, you do have to define the type of data that you are expecting in a method. So in this case, even though we have an arbitrary class, and it doesn't matter if it's this one that I've created called car, it doesn't matter if it's a primitive type like int or byte, and it doesn't matter if it's a more well-known object like string, you still have to define what type of data you are expecting for this variable. So in this case, we have a variable called myCar that is of type car, and we're doing something with it. So we are actually retrieving some data like the year and the model and the make, and we're using that to compile a string that we output to the user to tell them whether or not they were successful in setting the speed of this car. So how do I know? How do all of these methods work? What does the car class actually look like, and how does Java know? Because you can tell at the very top there's no reference to a car.java file. Well, if I take a look at car.java, we can see that I've defined it elsewhere. There's a whole bunch of methods and fields. The very first thing is a constructor called public car that accepts a variety of data, like the make, the model, and the year, and I set the private variables equal to each of those that's passed to me. And then there's some of these interesting functions, or rather methods, that we had seen before. So we want to set the maximum speed of the car. And so it's probably pretty reasonable to assume that a Ferrari is a little bit faster, has a little bit faster of a top speed than a Camry. So we could set then a max speed for the Ferrari to be a little bit higher than the max speed of, say, a Camry or some other car that we might instantiate in this case. Now, what we will do in the set speed is we will accept a speed from the calling class, and we will test to see if the speed that they are requesting exceeds the maximum possible from this car. If that's the case, then we tell the user, or we tell the calling code that we cannot do that, and we will return false. Otherwise, we will set our current speed equal to the speed that they requested and return true, that it was successfully returned. Now notice that when I define each of these methods, I define a couple of things. First of all, whether it's public or private. You can have private methods, which means that only other methods within the same class can access those methods. But in this case, all of these methods were accessed by another class altogether. that code 18 class. And so what I'm doing here is making sure that these methods are accessible to that one. And then the next one is the type of data that this method is supposed to return. So void means that we're not going to return any data whatsoever. Boolean means that we're going to return either true or false. We can have it return an integer. We could have it return a complex data type like a string. We could even have it return a car if we wanted, or not an actual car, but the type that we are now calling car. It all depends on what we want. So then we have a bunch of get methods that allow us to actually retrieve the information that we've stored in the field variables in this at the top of this class. In this case, we want to get the make and the model of the car. We have functions, we have methods available to us that do all of these things. So what happens? Let's say that I remove all of my class files, and all I have then are in the source directory is all of the Java files that I've used, that I've created to develop all of these applications. Well, what happens when I compile this code 18 into an application? So after it compiles it, notice that there's no errors, thank goodness. I can do an ls and see what is here. So here we see that we have generated a code18.class file, which the Java virtual machine will use to run this code18 when I type in Java code18. But also, because I referenced an object called car, it looked in the same directory to find if the compiler looked in the same directory to see if there existed another file called car.java, which would indicate to it that there is an object called car that it can also compile into bytecode. And so you can see that it also has compiled car.class automatically for us, so that we don't have to do anything. Just by convention, we are lucky in that it knows to look in the same directory for this information and compile it as necessary. So when I want to then run my code 18, I don't have to do anything special. I don't have to link this car class to back to this one as well, just to say that it's sort of a dependency of some kind. It will actually perform the search at the current directory for us. So when I hit Java code 18, okay, all of that stuff later is that, okay, now we've set our Ferrari to go 155 miles an hour, and the Camry is unable to match that particular speed. So this is sort of a quick introduction to methods and what all of this means, but we can take it a step further as well. So this is a bit important. Whereas before the break I had talked about how Java passes data by value, not by reference, this can actually cause quite a bit of confusion. And unless you are familiar with Java, this might actually make you take a step back. But realize that this is not meant to be confusing. It just depends on how you think about this. So there's two very important things that you have to remember about Java. First of all, when you're passing parameters in Java, it's not passing by reference, nor can you force it to pass by reference, but what it is passing is the value of the variable. That's the first thing that's important to realize. It's not passing by reference, it's passing by value. The second important thing to realize is that for non-primitive objects, so for anything that is a string type, a car type, code 19, any of these classes that we have created, what it is storing, what Java stores in the variable is not the instantiated object, but rather a reference to the instantiated object that exists on the heap. So right here, if I were to somehow look at what's this code, let's see, all the way up here. So I have a class called point, and I'm putting it into a variable called a. If I were to actually able to look at the contents of the value of a, it is a reference. And so that's where this confusion might stem from. And so realize that this is not meant to be confusing, just that the value of complex objects is actually a reference to the instantiated version of that object. So this has important implications for us. What sort of things might happen if we wanted to do something like this? So let's say that I created two integers, first num and second num, and I gave them some values, like first num has the value 1, second num has the value 2. Now what I want to do is create a method whose sole purpose in life is to swap the values of two integers. So you can see that I have defined a swap method somewhere, and I pass in the first number and the second number. And if I take a look at this function, what it is supposed to do is this. So it takes an integer x and an integer y as parameter. It stores into a temporary value, into a temporary variable, the value of x, and then it sets x equal to y, and then it sets y equal to the temporary value. So in effect, these values should be swapped, right? So yes and no. It depends on the scope. So if we were to do this swap on first num, because we are passing in by value, we're passing in not a reference to these two variables, but rather the variable, or rather the value that is contained by these variables, what is happening is that in memory, a copy exists. So we have in memory a location for first num, we have in memory a location for second num. And right now, first num has the value 1. Right now, second num has the value 2. And when I call this method up here, swap, what is happening is that I am now creating two new variables called x and y within the scope of this swap method. And right now, those two variables, the values of the initial two, first num and second num, were copied into x and y respectively. Now, the swap does occur in x and y. So at the end of this method, x does contain the number 2. Y does contain the number 1. Those are effectively swapped. But they are different variables. They are within the context, within the scope of this swap method. So when this method ends, those variables, x and y, disappear. There's no remnants left over, and first num and second num remain unswapped. Now, this should not hopefully be all that surprising if you are familiar to languages that pass data in parameters by value rather than by reference. If you were in C, for example, what you would probably do is pass them in by reference instead, and then you would actually be able to swap them in their original locations. You can't do that in Java. That's not something that you'll be able to do because all of these values are passed by value. Now, where this gets interesting is when we start doing a swap within an object. Let's say that I create a new object that's very, very simple. I'm just going to call it a point. So notice here that I've created a new class, and yes, you can create classes within another class, just like you've done here. So there's a class called point, and it is available only to this one class that I've already defined elsewhere, because it's a private static class. Okay, so within it I have two field variables, x and y, and I have a constructor for this class that accepts two parameters and sets these values x and y equal to something. Okay, got it? So there's an object called point that allows me to set two variables within it. So it's like a point in that it has an x coordinate and a y coordinate. Really could be named anything in this case. Now what's going to happen is that I'm going to instantiate a copy of this class and pass in some variables or pass in some values to it so that the x field in the point class has a value of 3, or rather the x field in this instantiated form of this x class or this point class has a value of 3, and the y field in this instantiation of the point class has a value of 4. Now notice that I actually have here another swap function altogether. So there is something called overloading that you can do, which is to define two methods of the same name but that have different parameters, and Java will be able to find the appropriate one depending on the type of values that you're setting it. So I do have two swap methods here, but don't get confused. One accepts two integers, and the other one accepts one variable called a that is of type point. So now what's happening is that we're going to attempt to swap these two numbers, x and y, within the context of this object. Now you can use this dot notation to access the fields and the methods of the class that you're working with. So just like we had called the substring method, for example, from that string a few examples ago, we had done myString.substring. That was a method that exists within the class. We can use the dot notation to access it. So what is happening here is that we are swapping these. So now, hopefully there should be no question that this swap does what it does. The swap method does what it's supposed to do by the end of the method. It is going to swap the values x and y. But now the question remains, besides the fact that this is all sort of leading up to this point, is that will this remain swapped when you look at the values of x and y after running this swap method, or like the very first swap method, will things remain the same? Will things remain unswapped? So here's a poll. Who thinks, and everybody has to raise their hand, who thinks that the two values will remain the same? Okay, and who thinks the two values will actually be swapped after the swap function? Okay, and that is actually the correct answer. And the reason for that is that we have passed in this variable by value. Recall that because this is not a primitive data type, the value for this variable is actually a reference to the instantiated object somewhere in memory. So there is an object that's sort of nebulous in memory that's of type point, and it's been instantiated. It has an x and a y, and the x we had set to 3, as I recall. In this object, the x had been set to 3, and the y had been set to 4. So when I pass in by value the reference to this object from A into this swap, so now there's another variable for this swap function that is called point A. So now there is, within the context of this function, there is another variable called A, and it is of type point, but the value is the same of those. But because that value is a reference to this object, it's referencing each of these, A from this method and A from the calling method, both point to the same instantiation of the object in memory. So what this means is that when I perform this swap, I'm performing this swap on the object, the instantiated object, and because both of those point to the same object, that method or this actually sticks. And this is what is important to realize between passing by value and passing by reference in Java. So long as you remember those two important things, values are always passed by value, parameters are always passed by value, and that objects, non-primitive types, the value of those is by reference, then hopefully this will make a lot more sense. So to make this make sense, let's run code 19. Oh, I have to compile it first. All right, so if you see no class definition found error, that means that you forgot to compile it. And so I had assumed that I had compiled everything before, but I deleted it also, so I just think I will quickly recompile everything so I don't see that again. And what we see as a result is exactly what we had predicted. First number before the swap and second number before the swap are 1 and 2 respectively. We run that swap method on these integers, but because the values were passed, the parameters were passed by value, the original variables did not change. So after the swap, they remain the same. Now, because of this object, even though it was still passed by value, it was the value itself was a reference to the same instantiated object in memory. Before the swap, we had 3 and 4, and after the swap, we had actually performed the swap that we had wanted, 4 and 3. Any questions on this? Yes?
So each function has its own scope. Is that why you could use A both in the main function and A in the swap function?
Yes, each function has its own scope, assuming that the variables were defined within that function. So in this case, I have some field variables up here, first num and second num, which means that because they were defined up here for the class, that any method in this class has access to them. So what could happen is that I could change this swap function to not use x and y, but instead to use first num and second num. So first num here and second num. And now what will happen here is that this will actually work like we expect, because it is actually performing the swap on the field variables, on the variables that actually contain the values 1 and 2. But this has nothing to do with the values that were passed into it in this case, if that distinction makes sense. So again, yes, we have two variables called A, but because each were defined locally within the scope of their own method, this A is local only to this method, and down in main, this A is local only to this method. No other methods within this class will know what the variable A means. It's undefined in other methods. Yes?
If you had passed like A dot X, would that have been passed by value even though it's part of an object?
Yes, and this is actually a very good modification to this. So what if instead of doing this, I had done this instead, a.x and a.y. Now let's see what happens if I try to compile this code and rerun it. Java code 19. It says first num1, first num2. So recall that I had made two changes, right? Let's see. The first change that I had made was to the integer swap function. And okay, so I'm sort of convoluting the problem here. So let's not look at ax and ay right now, but only these two. These two are swapped because I actually swapped the field values themselves. And so recall that we are then not using the data that was passed into these methods at all, thereby completely getting around the issue that we were trying to discuss. Now, of course, that same thing also gave me the issue of, okay, well, it was when I called the swap method again, it was ignoring ax and ay, and it was then performing the swap again on first num and second num. But let me revert back to this, to what we had before. And so before this was the value x, and let's see, this was the value x, this was the value y, and this was the value y as well. Now let's see what happens again to this. Got to compile and then rerun, so compile first. Okay, so now we're actually seeing what we had expected. Again, this was the first initial swap that we had done, just like we had seen at the onset of this discussion. The swap did not actually occur because of this passing by value problem that we just talked about. Now what we had done was not passed in an object, but we had passed in what are two integers. And so a.x is an integer, a.y is an integer, so it copied those values, and it's the exact same problem all over again. It did not actually perform the swap on a.x itself and a.y itself, but rather copies of those. Yes?
If you had two swaps that both took in points, like swap point A, they both took in points, does it go like by where it is located on the page?
But so I'm not quite sure what.
Swap. Right now you have two methods, swap
Mhm.
and swap. They're both called swap, and the only difference is that you take in a point and the other one takes in two integers.
Oh, you're saying what if I had.
Another swap that just took in a point, and it was lower on the page than the one that took in point A.
So-
Which one does it reference?
Okay, so I think you're asking if instead of overloading like this, what I had done was created two method declarations that were the same.
Well, yeah, because they're both swap. It's just
Right. So I think in that case, you'd probably get a compiler error that it is the function or the method has already been defined in that way, and it probably won't let you actually have that, that question about which one would be called. I suspect you'd get a compiler error in that case if you have exactly the same methods. Yes?
Why would you want to exactly overload a method? Why not just give those two different names as they do two different?
Well, I think this is, why would you want to overload a method? Well, it is for precisely this reason. It is because what we are doing is still a swap, but it allows us to perform a swap on different data types. So this is really useful. There's probably a lot more, I know there's a lot more examples besides this that it would be useful, and it would become kind of unwieldy if we started having swaps for lots of data types. So maybe our sole purpose in creating a class was to swap not just integers, but maybe strings or maybe doubles as well. And so you're starting to get a whole bunch of methods that would then have to have specific names for each of these, like swap integer, swap double, swap point, for example. And that can become quite a bit unwieldy, whereas with this, it simplifies it to the point of all you have to know is that it's a method called swap, and hopefully, unless you're looking at the Java doc, you can sort of cross your fingers and say, I hope it accepts the parameters or the types of data that I'm sending into it. Other questions? Yes?
One more question. Do you have class, the car class by itself in its own Java file, just for organization, or does each class have to have its own Java file?
So, okay, so let's take a look at this as an example. So what we had done was we had created a class within this class. So they're both defined within this one file. And what I can see is that here's our code19.class. And because point is sort of within that code 19, it does create a separate class file for that class, but it just associates it with code 19. So we could have defined, let's see, could we have, I think you can define a number of, well, by convention, it's better to have each class in a separate file. So for example, code 19 is better to have separate from car.class, or rather code 18 is better to have separate from car.class just because they're sort of independent entities. But when we had embedded point to be sort of within that class, then that was acceptable in this case, and it does actually take it. Yeah.
You cannot have two top-level classes in a Java class.
Right.
You can have many nested classes as one. You have two. You can.
You can have two top-level classes, or they'll just generate two different class files, and it's like,
Has that always been true in Java? Initially, you
Once you close the class, you can start up.
So yes, so the point is that no matter how many classes you have in your Java file, it will create a separate class file for each of them. If they're both top level, it will actually create two separate class files. I don't think I have an example here. It would create two separate class files, each with their respective top level names. So if point was not sort of within this code 19 class, then it would have its own point.class file. But in this case, because it is actually contained within code 19, then it is reflected in the name of this class file. Other questions before we move on? Yes?
In this example, what would happen if a different file wanted to reference that point class? Would it find it?
What would happen if another file wanted to reference this point class? It would not be able to find it, and the reason for that doesn't deal so much with this the class file that exists here, but because within code 19 we've defined it to be private. So it's private only to the code 19 class, and other classes cannot access this particular class. Had I made it public, then yes. But then we would have to access it not directly through point. It would have to be like a code 19. We'd have to reference it through code 19 itself. Other questions before our final chapter in Java? So code 20 sort of takes all of these things and does something with them. But it does it with one very, very important additional thing that you're going to see all the time in Android. And what is happening in Android is that Google has developed a lot of classes for you. There's a whole bunch of classes that you're going to start working with to create an Android application. One of them, just as an example, is called an activity. So for you to create an actual Android application, you're probably going to have to do something with activity. And it relies on something very important to this idea of object-oriented programming, and that is class inheritance. So they have defined a class somewhere, and in this case, I have defined a class somewhere as well. But you can define sort of subclasses that inherit the properties of its parent class. So here we have an example. You can see that we have a variety of interesting variables here. We have a Mac Pro, MacBook Air, and an Xserve, and each of these have a different data type. Mac Pro is a computer, the MacBook Air is a laptop, and the Xserve is a server. But what's interesting, I think, is what is defined in each of these classes. Now, what's pretty interesting, I think, is that there could be a lot of things inherently the same between all of these three classes of computer. And I use the word classes outside of the scope of programming. What I mean to say is that within these three actual physical objects that exist, they're all at a base level a computer. So there's sort of inherent properties that all three of these share. So some properties might be, for example, the CPU speed of this computer. Another property might be how much RAM it has. All of these three computers, even though they are very different when we actually take a look at them, they do share some similarities. So for this reason, we might define a class, like a computer class, for example, that allows us to define a lot of these properties inherent to a computer itself, like a make, model, what its processor speed is, whether or not the computer is on, so on and so forth. and we can take all of this data, have a constructor for it, and have a whole bunch of setters and getters. We could turn it on the computer. We could turn off the computer. We could ask the question, is it on? We could do a whole variety of things and implement a whole